Okay, level 3 is writing equations still, but we're not going to solve these necessarily, not in these first two. We're just writing equations in terms of a single variable. So in number 3, it says perimeter of a rectangle is 48 units. Write the function a of w, representing the area of the function of the rectangle as a function of its width, w. Okay, so a lot of w's going on here. This is what we're going to do. We're going to break it down a little bit. So if I have a rectangle, and I'm going to label, okay, the length, the width, and I know opposite sides are equal. So to find the perimeter of this rectangle, I'm going to take L plus W plus W. So I'll say 2L plus 2W. And now this perimeter of the rectangle, our problem tells us that it's 48. Okay. So now the question asks me to write the function for the area of the same rectangle, but only in relation to W. So I know that the area of a rectangle is equal to the length times the width. Well, the problem only wants it in terms of width. So I need to somehow make an equation or substitute or get rid of this L in some way in terms of the width. Well, since I have this equation for the perimeter and I have L's and W's, I'm going to solve for L so I can get an expression that I can substitute in for the area. So I'm going to go ahead and subtract 2W. And then divide both sides by 2. And once you divide, you got to divide each term by 2. So L is going to equal 24 minus W. So now that I have an expression for L, and it's in relation to the same rectangle that I'm talking about the area of, I can substitute this in for L, and I'm going to get rid of the L and only have W's in my answer. So A of W, this W, whatever that variable is, should be the only variable on the other side of the equal sign. If you have anything else, you need to, something went wrong, something we need to fix. Okay, so that's kind of a clue on what variable you should only see on the other side. So, okay, I'm going to substitute 24 minus W for L, and then you still have that W. The only thing to finish this up, you're going to distribute that W inside. So 24W minus W squared would be your final answer. Okay, so it's a little bit different. It's a little, we're not solving for anything. You're only creating kind of one equation. In the end, you're not going to get an answer for these, at least for these first two. Okay, let's try number 4. It says the volume of a cylinder can be found using V equals pi r squared h. If the radius of a given cylinder is 1 more than twice the height, write the function VH representing the volume of the cylinder in terms of its height. So again, this h in here tells me that the only variable on the left-hand side should be an h. So, okay, we've got the volume of a cylinder can be found using V equals pi r squared h. We only need h's in there, so we need to find something to replace the r with that has a variable h. In the problem it says, if the radius of a given cylinder is 1 more than twice the height. So here's my key. Here's a piece of information that I can write a second equation for, so I can get rid of that r in that volume formula. So it says, if the radius of a given cylinder is 1 more than twice the height. So remember this important word in math, this word is, that means equals. So the radius, we're going to use r, is, means equals, 1 more than twice the height. Well, 1 more means an additional 1, so we're going to add 1 to twice the height. So 2 times h, and h will represent the height, plus 1. You could have also said 1 plus 2h. That would have meant the same thing. So now that I have that for r, I have something that I can substitute in for my volume formula. So remember, volume was pi r squared h. So I'm going to take 2h plus 1 and put it in for r. So volume in relation to h, the height, will equal pi times 2h plus 1 squared times h. Now here's your chance to not break math. You want to multiply 2h plus 1 out twice, then multiply it by that last h. So this will be pi 4h squared plus 4h plus 1 times h. And then I'm going to go ahead and multiply the pi in. So it'll be 4 pi h squared plus 4 pi h plus pi. And now I'm going to multiply by h one more time. So I have 4 pi, 4 pi h cubed plus 4 pi h squared plus pi h. Now it doesn't matter if you write like this h cubed before the pi. You could say 4h cubed pi plus 4h squared pi plus h pi. It doesn't matter where you put the pi because it's all being multiplied, so the order doesn't matter. But it does matter that you've got the 4 and the exponents. Obviously those matter. So the volume in relation to the height is going to be 4 pi h cubed plus 4 pi h squared plus pi h. Okay, part 2. Okay, so the part 2 is writing the systems, and then we're actually going to solve these. So with h, it gets a little bit tricky. Okay, I actually took out number 5 in your notes, so we're going to use it as a warm-up problem later on. So let's go ahead and look at number 6. It says, George Washington was born 11 years before Thomas Jefferson. In 1770, Washington's age was 3 more than 7 times the age of Jefferson in 1748. Okay, take some time. If you need to pause it, think about what the problem is asking. These take a lot sometimes to conceptualize. So, okay, we got George Washington was born 11 years before Thomas Jefferson. So let's work on that first. So I'm going to use W to represent Washington and J to represent Jefferson. So George Washington was born 11 years before Thomas Jefferson. So you can do a couple things here. We can say Washington minus 11 because it was before, 11 years before. So we're taking 11 will be when Jefferson was born. Or you could say, you could add 11 years to Jefferson and it'll equal when Washington was born. So either way you think about it, if you're going back in time or if you want to go forward in time to get when the two men were born, it doesn't matter. I'm going to stick with the W equals 11, J plus 11, just because I like addition better. So, but whatever makes sense to you, if you're going to go back in time, you use the subtraction. If you go forward in time, you'll use the addition. Okay, the second piece says, in 1770, Washington's age was 3 more than 7 times the age of Jefferson. So, the difference between the 2 years that they're talking about, from 1770 to 1748, was 22 years. So, Washington plus 22 years. Okay, so after 22 years, between 1770 and 1748, Washington was 3 more, so 3 plus 7 times the age of Jefferson. Okay, so we'll go through that again. The ages between 1770 and 1748, that's a difference of 22 years. So Washington's age between those 22 years, so W plus 22, was or equals 3 more than 7 times the age of Jefferson. So 3 plus 7 times J. You could have also said 7J plus 3. Okay, so now that we have our system, we're going to go ahead and solve for W and J because B then asks what's the sum of the men's two ages. So I'm just going to go ahead. I think this lends itself really nicely to solving by substitution. So I'm going to take J plus 11 and substitute it in for W here. So I'll get, let's see, 33. So 30 equals 6J. So then J will equal 5. So J will equal 5, and then I'm going to go ahead and substitute that in to find out Washington. So Washington will equal 16. Okay. Now that's not our final answer. Remember back in our question, it says the last year that we were talking about was 1748. So these years down here, 5 and 16, those are the years that they are in 1748. The question asks us to find it in 1750. So in order, I'm just going to add 2 years to what we got. So Jefferson, that means Jefferson was 7, and Washington was 18. Okay, so keep working, keep trying different equations. If you get like crazy answers, chances are something in your equation was wrong. For the most part, you'll get really nice answers for these. So just try something. If something doesn't work out, go try something else in terms of an equation. So keep working. You guys are doing great. Keep it up.